So now we're going to look at another way that we can divide, and this is actually a shortcut, and it's called synthetic division. The problem with synthetic division is that you can't use it all the time. So let's look back at the examples that we did in the other video. So when we did long division, this example here, where we were dividing by a linear, anytime we're dividing by a linear, you can use synthetic division. So in this example, we could have done this with synthetic division. In this example, we were dividing by a linear, but the coefficient was not a 1. So technically you can do synthetic, it's just going to be a little bit, not trickier, but there's a couple of other steps, and we'll go over how to do that. That's pretty much your choice if you want to use that or not. I would recommend doing this with long division because of the extra steps involved, but that's up to you. In this last example that we did, we cannot use synthetic for this because we are dividing by a quadratic and not a linear. So when in doubt, use long division, but synthetic division is a shortcut. It's less work and it's faster. So I would suggest using that when you can. So let's go over an example. So here we have a division problem and we're dividing by a linear, so we can use synthetic division here. So here are some steps for solving using synthetic division. Now, we're going to go step by step. The steps look longer than they actually are, but we're going to go step by step. So your first step in using synthetic is to solve for the 0 of the divisor, and then write that number on the outside and draw an upside down division bar. So our divisor is x plus 5. So we're going to take x plus 5, we're going to set it to 0, and we're going to solve for x. So we get x is equal to -5. So when we're doing synthetic division, the whole point of this is to not use variables until the very end. So all we're doing is using numbers. So the -5 that we get, we're going to put that on the outside, and then we're going to draw an upside down division bar. Step 2, write the coefficients of the dividend in standard form with zeros in place of missing terms along the top row. So here's our dividend. The coefficients are the numbers in front of the x's, and we just want to make sure that it's in standard form, and if it's missing a term, we put in a 0. So here it's not missing anything because the exponents go 3, 2, 1, 0, so that's fine. So the coefficients in front of the x cubed, we have a 5. In front of the x squared, we have a 21. In front of the x, we have a -21. And then our constant is a -5. So we're writing the coefficients along the top. Step 3 is to bring down and rewrite the first coefficient in the bottom row. So the first coefficient is a 5. We're not going to do anything to that. We're just going to bring it straight down and rewrite it on the bottom. Step 4 is to multiply that number in the bottom row by the number on the outside, and then write that product directly under the next coefficient. So we're going to take the number on the bottom, which is 5, we're going to multiply it to the number on the outside, so that gives us -25, and we're going to put it underneath the next coefficient. So 21 is the next coefficient, so we're going to put it underneath. All right, step 5 says to add the two numbers that are in that column and write the sum in the bottom row. So we're going to add. So with long division, we subtract after we stack it. In synthetic division, we add. So that's another reason people like it, because if you forget to distribute your negative when you're subtracting, it messes things up with long division. So we're going to add 21 and -25. So that's going to give us -4. And then step 6 says continue until all columns are filled in. So if it's on the bottom, we're going to multiply it to the side. So -4 times -5 is going to give us 20. We're going to add -21 and 20, so we get -1. Multiply -1 times -5, so that's 5. Add -5 and 5, and that's 0. And then we're going to put a little box on that last number. So this last number is our remainder. So if we have a 0, like we do here, we're going to just realize that it goes in evenly, and if it's a number, then that's our remainder. So to write our answer, what we're going to do is use the numbers on the bottom. Actually, I'll go back to Step 7, write your answer with the numbers in the bottom row, and the degree will be 1 less than the original. So these numbers are the coefficients, and our original dividend had a exponent of a 3, so our answer will have an exponent that's 1 less, so it would be a 2. So this is going to be 5x squared minus 4x minus 1. So a lot less steps and a lot less time to solve this with synthetic. So let's look at another example. All right, so again, first step is going to be to take that dividend, and set that dividend, take the divisor, set the divisor equal to 0. So x minus 7 equals 0, so we get x equals 7. So 7 is going to be the number on the outside. Okay, then we're going to write the coefficients along the top. If we are missing something, we'll put in a 0. So the exponents go 3, 1, nothing. So we're missing the x squared term. So in front of x cubed, we have a 1. Since there's no x squared term, we're going to put a 0. The x term is a negative 57, and then the constant is a 56. Okay, bring down the first term, so we have a 1. 1 times 7 is 7. Add 0 and 7 to get 7. Multiply 7 and 7 to get 49. Add negative 57 and 49 to get negative 8. Multiply negative 8 times 7 to get negative 56. And then add to get 0. And that's our remainder. Since we started out with an x cubed, we're going to drop it to x squared in our answer. So we have a 1x squared plus 7x minus 8. And if there was a remainder, we would write the remainder like we did before, where we would have, if it's a positive or negative number, we would put plus or minus depending on it. This number would be the numerator, and then our divisor would be the denominator. Okay, the last example we're going to look at is when we're dividing by a linear that has a leading coefficient. So in the last two examples, it was just x plus or minus a number. But now we have a number in front of the x, and that's called our leading coefficient. So like I mentioned earlier, I would suggest doing this problem with long division. If you do it with long division, you're going to get the answer right away. If you want to use synthetic, which is fine, there's a couple of extra steps that you need to do, and that's in this box listed over here. So the first step is going to be the same. We're going to take the divisor, 5x plus 1, and we're going to set it to 0. So 5x equals negative 1, x equals negative 1/5. So negative 1/5 will be the number outside. So another, downside maybe of doing synthetic is that sometimes, I'd say most of the time, you do have a fraction that you're working with. So if you don't like fractions, you maybe don't want to do this way. The part that's different is that instead of putting the coefficients along the top, like the ones that we have here, 10, 37, 37, 7, we need to divide by the leading coefficient on all of those numbers. So right here we can see that the leading coefficient is a 5. So when it's a 1, like the other two problems, we don't do anything. We just write the numbers as is. But if the leading coefficient is something other than a 1, we have to divide all of the coefficients of the dividend by 5. So instead of writing 10, I'm going to put a 2 here, and I'm just going to write that here, that's 10 divided by 5. And we get 2. And then we're going to do that for all of them. So 37 divided by 5, we're going to end up with a fraction. 37 divided by 5 is again a fraction. 7 divided by 5, also a fraction. All right, then we're going to follow the same steps as before. So we're going to bring down the first term, so we have a 2. We're going to multiply 2 times negative 1/5, so that's negative 2/5. Now when we add 37/5 and negative 2/5, that gives us 35/5, which is 7. So even though we have fractions, they kind of work out. 7 times negative 1/5 is going to be negative 7/5. We're going to add 37/5 minus 7/5, so that gives us 30/5, which is just 6. So again, that kind of gets rid of that fraction. 6 times negative 1/5 is going to be negative 6/5. And then that, when we add these together, we're going to get 1/5 and put a little box. The second part to this that's different as well is that once we've gotten our remainder, we have to then multiply the remainder by the leading coefficient. So the two steps that are different with this type of synthetic than when it's a leading coefficient of 1, you have to take the leading coefficient and you have to divide all of the coefficients of the dividend by that number, and then you have to multiply the remainder by that leading coefficient. So if you're going to forget those two rules, just do this with long division and you'll get the right answer. So what we have to do here is we have to multiply by 5, because that is what the leading coefficient is. So we have 1/5 times 5, which gives us 1. So our remainder is really 1. So we're going to drop a degree from our original, which was x cubed, so now it becomes x squared. So we have 2x squared plus 7x plus 6. Our remainder is now a 1. So it's plus 1 over our divisor, which is 5x plus 1. And again, I would recommend doing this with long division because of the extra steps that are a little bit confusing, but because it is the divisor is a linear, you can use synthetic, and this is how you would do that.